Oscillations. We will be study about oscillations. Okay, what is oscillation? How to work the oscillation in oscillation, simple harmonic motion, introduction, oscillatory and simple harmonic motions, and many different types of heading. We will be study about the headings. Okay, and differential equation of simple harmonic motion. Okay, SHM, simple harmonic motion. Introduction. What is simple harmonic motion? What is simple harmonic motions? Okay. Introduction. Motion of a clock pendulum. Motion of clock pendulum. Motion of clock pendulum. Okay. Motion of clock pendulum. Motion of a clock pendulum. Balance wheel of a clock mass attached to a suspended spring. Suspended spring. Mass attached to a suspended spring. Okay. Motion of a clock pendulum. Motion of a clock pendulum. Balance a wheel of a clock mass attached to a suspended spring. Vibrations of prongs of tuning fork. Tuning fork of tuning fork. Of tuning fork. 1 minute. Of tuning fork. That is a fork. Up and down motion of needles of sieving machine. Up and down of needle of a sieving machine. A bar magnet suspended in uniform magnetic field. A bar magnet. A bar magnet. A bar magnet. A bar magnet suspended in uniform magnetic field are some of the familiar examples of simple harmonic motions. Okay? Every oscillatory motion is simple harmonic in character and continues due to the interaction of inertia and elasticity. When an oscillator is displaced from its position of equilibrium by application of a force and thus doing work on it, a restoring force comes into play, tending to bring it back to its equilibrium position. According to Hooke's law, this restoring force is proportional to displacement and depends upon the elastic properties or elasticity of the systems. As soon as the restoring force tries to bring the system back to its equilibrium position, the property of inertia opposes this change in velocity further. When the system reaches the equilibrium position, it overshoots the mark and moves beyond the mean position again due to inertia of motion. The motion continues till the deforming force due to inertia developed brings the system to rest. The restoring force again then sets the oscillators into motions back towards the equilibrium positions. Throughout the process, the total energy remains conserved. Only the conservation of potential energy to kinetic energy and vice versa takes place within a limits set by the potential valve. Okay, introduction is in there, and we will be study about oscillatory and simple harmonic motion. What is oscillatory and what is simple harmonic motions? Okay, thank you. Oscillatory motion. A motion which repeats itself after regular intervals of time is called periodic motion. It's called periodic motion. Okay? As example, watch. A motion which repeats itself. A motion which repeats itself after regular intervals of time is called periodic motion. If a body in periodic motion executes to and fro motion about a fixed reference point, it is said to be have an oscillatory motion. Okay? Before oscillatory motion, we will be know about periodic motion. Periodic motion. Okay? A motion which repeats. A motion which repeats itself after regular intervals of time. Intervals of time is called a periodic motion. Okay? A motion which repeats itself regular intervals of time is called periodic motion. And next is oscillatory motion. Oscillatory motion. If a body in periodic motion, what is periodic motion? A motion which repeats itself after regular intervals of time is called a periodic motion. As example, a pendulum of clock. The pendulum of clock which repeats itself after regular intervals of time. Okay? That is known as periodic motion examples. Okay? And oscillatory motion, if a body in periodic motion, executes to and fro motion about a fixed reference point. It is said to have an oscillatory motion. Okay? Oscillatory motion. If a body in periodic motion executes to and fro motions about a fixed reference point, it is said to have an oscillatory motion. Okay? The term oscillatory motion is not restricted only to displacement of a mechanical oscillator, but it may be any physical quantity. For example, in electrical system, an oscillatory variation of charge, current or voltage may take place. Okay? What is simple harmonic motion? What is simple harmonic motion? Simple harmonic motion. What is simple harmonic motion? We will be knowing about simple harmonic motion, SHM. Simple harmonic motion. Okay? When a body moves such that its oscillations is always directed towards a certain fixed point and varies directly as its distance from that point. The body is said to be execute simple harmonic motion SHM. Okay? when a body when a body when a body moves such when a body moves such that its acceleration is always directed towards a certain fixed towards a certain fixed point and varies directly as its distance from that point. The body is said to execute simple harmonic motion. Simple harmonic motion. What is simple harmonic motion and what is the definition of simple harmonic motion? When a body moves such that its acceleration is always directed towards a certain fixed point and varies directly as its distance from that point to the body is said to execute simple harmonic motion. For such a motion to take place, the force acting on the body should be directed. For such a motion to take place, the force acting on a body should be directed towards the fixed point, okay? And should also be proportional to displacement, okay? The distance from the fixed point, the function of the force is to bring the body back to its equilibrium position, and hence this force is known as a restoring force, okay? The function of force is to bring the body the function of force is to bring the body back to its equilibrium position, and hence this force is often known as restoring force, okay? The function of force is to bring the body back to its equilibrium position, and hence the force is often known as restoring force. It should be noted that all the periodic motion are not SHM. All the periodic motion are not SHM. For example, the motion of the earth around the sun and the motion of the moon around the earth are periodic but simple harmonic, but not simple harmonic. The motion of the earth, the motion of the earth, the motion of the earth around the sun, the motion of the earth around the sun, and the sun, and the motion of the moon around the earth, and the motion of the moon around the earth, around the earth are periodic, but not a simple harmonic, but not a simple harmonic motion. What is simple harmonic motion? When a body moves such that its acceleration is always directed towards a certain fixed point and varies directly as its distance from that point, the body is said to be execute such a simple harmonic motion. But the motion of the earth around the sun, this is sun and this is earth. Okay, this is sun, and this is earth. Moves around the sun, and this is earth, and this is moon. This is moon. Moving around the earth is not a simple harmonic motion, but periodic motion. Both are periodic motion, but not a simple harmonic motion. Okay. However, the reverse is true. All simple harmonic motion are periodic. All simple harmonic motion are periodic. All simple harmonic motion are periodic. Or simple harmonic motion has a definite frequency and hence has fixed time period, which makes it a periodic motion. However, the reverse is true. All SHM simple harmonic motion are periodic, but all periodic motion is not simple harmonic motion. All periodic motion is not simple harmonic motion, but all simple harmonic motion are periodic. A simple harmonic motion has a definite frequency and has fixed time period t, which makes it a periodic motion. Okay. Next is potential well. What is potential well? We will know about potential well in next heading. Okay. Thank you.